Hey, g'day, it's Prezzo. Thanks for stopping by and I hope you're well. Now this is episode 6 of working on this home-built 4-facet drill grinding machine. There's a playlist, links up above there now, you know what to do. And in today's video I want to focus on the actual use of the machine, what I've learned about grinding drills using it, and what its overall capabilities are. Now I also went ahead and I've made a number of upgrades and accessories for the machine. Now I did all of that off camera because I just wanted to get it done and I want to wind up this series on this machine. But I will take you through each of the upgrades and accessories and we'll talk about why they were necessary and what capabilities they bring to the design. So let's look at them, but in no particular order. Now the first one is I've got a new belt for the machine. This was the old one. It's a urethane material and it just became brittle and cracked. The new one has one of these little aluminium joiners and they just simply push into the open end of the belt to make a complete loop. So I've got enough spare material here for 2 more belts and a spare joiner. Now these, they run really well. They're very quiet and very smooth, but you can't overly tighten them. And this one does tend to buckle a bit on one side when you start the machine. And that's because these CBN wheels are quite heavy. So I'll just show you what I mean. Watch the top of the belt. So you see it buckle up on the top side, and that depends on the direction of rotation, but it settles down once the wheel comes up to speed. So that's the first thing that I did. I've also ordered a 200 grit CBN wheel. Now this one's 80 grit. I think it's too coarse. When I read through John Moran's notes, he's the designer of this machine, he recommended 200 grit to be about the middle of the range. So when I get that new wheel, it'll be exactly the same dimensions as this one, so I can swap them out without having to change anything else about the design. Okay, I want to shift the camera and get down a bit closer and we'll talk about some of the more interesting upgrades. First upgrade I had to make on the machine was some way of stopping the face of this collet nut from touching the surface of the CBN wheel. And in the last video I showed what was happening there. If you look at the face of that collet nut now, there's a number of nicks and cuts where I ran the 2 of those together. And you can see here that when I try to advance the collet chuck past the face of the wheel there, it gets to a certain point and it does touch. Now I couldn't figure it out, but it's on the cab model I could see that it actually cleared. And in fact, if I drop the trunnion down to the angle that we need for the primary relief, you can see it passes the face of the wheel quite easily. But bring it up to the angle for the secondary relief and you've got a problem. Now of course that problem gets worse as you advance the collet chuck toward the wheel as well. So during the grinding process there's a feed screw at the back here. You advance the collet chuck slowly and that grinds off the point of the drill bit progressively until you get the angle that you want. So what I've done is I've made a stop. Let's have a look at that. So my solution for this problem with the collet nut touching the grinding wheel is here. This is just a little adjustable stop. So the good thing about using this V-slot material for the carriage is that it's got a number of slots in it which can be used to take accessories. And these use a flat nut with a 5mm screw thread in it. This is just a piece of aluminium material and there's a stainless steel locking screw here. So what I've done is I've moved the collet nut over as far as it can go and then just taken it back a little bit, and then I can put that stop into the slot in the front of the aluminium extrusion, slide it along until it touches the wheel underneath the carriage, and I can lock it in place there. So now when I'm doing the 4-facet grind on the drill bit, I can bring that across and it'll stop before the collet nut hits the wheel. Now I didn't want that stop to be permanent because I needed to have another accessory to go on the machine where this would get in the way. So when we're using that accessory, we just slide the stop down to the end or take it off altogether, and now you've got the full range of movement in the carriage. So let's have a look at this other accessory. So this accessory here is called a split point fixture. Now this is described in John Moran's notes on the build for this 4-facet drill grinder as an optional extra. And although you don't need a split point grind on the end of a drill bit to make it cut, it does have a number of advantages, and this little fixture was very simple to make. Now you'll notice it has 2 drilled holes here for dowel pins, and this is exactly the same layout of holes that are used on the base of the collet chuck. So in operation, you simply put the dowels into those pre-drilled holes, and that holds the collet chuck at an angle of 35 degrees from the vertical. And to mount this onto the grinder, there's a single drilled hole down here with a tapped thread, and there's a single screw that holds that in place. So I'll just get this in place and then we'll look at how that might work. So there it is fitted there now. I'll turn this around so you can see it a bit better. So there it is there, mounted on the side of this upright which supports the trunnion, and like I say, you just simply put the whole collet chuck assembly into that pair of dowel holes there, and then with the drill point extended the correct distance, and it's not at its correct position at the moment, we can run the drill bit in against what is essentially the left-hand edge of the grinding wheel standing in front of the machine, and with careful alignment and some other setting up that you're required to do, you can do a split point grind. Now this is one that I've already done, and we'll look later on at specifics about the geometry of that drill point and why it turns out that way. But I've used it, works really well, but it does require another stop to be set up on the carriage, because you must stop the drill bit at a very precise location. So here's the stop that I made for the split point grind when we're doing that particular operation. When you're doing just a regular 4-facet grind, you don't need the stop, so it just sits down below the level of the top of the extrusion here. And when you want to do the split point grind, you position that arm vertical, or roughly vertical, and lock it with the screw here. Now, when you extend the carriage to the right, it hits the end of this feed screw and prevents it from going any further. Now there is a micro adjustment on that, and there's a spring here, so once you set this, it should stay set and you don't need to mess around with it. Now initially when you're setting this up, you do need to do a number of test grinds and observe what's happening on the tip of the drill as you would make this adjustment here. When you're satisfied you get it right, you just leave it alone. I guess you could put a set screw in the top there, but I think with the spring there it's going to be fine. So if you're not doing split point grinding, just loosen that little screw there, drop that out of the way, and then you go back to your regular 4-facet grind. Now before we can do any grinding on our blunt drill bit, we need to set the stick out from the point of the drill back to the face of the collet nut. Now these two little gauges here are for doing that setting. These have been laser cut from 3.2mm thick acrylic, and they've got a dimension engraved on them. And there are two sizes. This smaller one here is for doing the 4-facet grind. This bigger one is for doing the split point grind. Now you need to extend the drill bit further for the split point because of the inclination of the axis of the drill bit to the face of the wheel. And the way this would work is you'd put your blunt drill bit into the appropriate size collet, have the nut done up finger tight, and then take your setting gauge, put it against the point of the drill and slide the gauge back until it makes contact with the face of the collet nut. Now then you can tighten the collet nut. Now that does move the collet nut slightly laterally back toward my hand, but in reality it's not an issue. For the split point grind, we just extend the drill bit further and do the same thing. So you slide that back and lock the collet nut. Now you don't need to worry about the horizontal alignment of the drill cutting edges. We're going to do that in another jig at the next step. This little accessory here is a jig for setting the cutting edges of the drill bit horizontal relative to the bottom of the collet chuck assembly. It's got a pair of holes here, and they are exactly the same spacing as the dowel pins on the bottom of the collet chuck assembly. And on the front of that piece of aluminium there's a piece of acrylic, and it's got a scribed line set on the back of that screen there. Now once again, this is just all laser cut, and I was able to get the dimensions for the position of that scribed line off the CAD model. Now there are slots in the screen there, so you can adjust it if necessary, but with that screen set level with the bottom of that aluminium base, it's correct. And the way this works is you'd put the collet chuck assembly into the holes where the dowel pins are, and then you look through the screen and you set the drill cutting edges parallel or level with that scribe mark, depending on which side you're looking on. So with the two locking screws loose, we can rotate the whole collet chuck assembly, and then you just simply look through there And to do this, you've got to look straight on at it, otherwise you get some parallax error, and you may need to have some sort of magnification if you're doing a very small drill bit. So let me just do this, and I find it easier if you close one eye. And there it is there. So when you've got that right and you're happy that it's set level with the scribe mark there, you lock this screw here, and then on the back you rotate the index ring around until it's touching the stop, and then lock that one there as well. So now you can rotate the drill bit 180 degrees and ensure that the drill cutting edges are level. Now, what do you do if you're using the extended stick out for the split point grind? And because of the position of the screen there, that wouldn't work. But what you can do is you can put the pins on the side of that setting gauge and slide it back. And that way you can do the setting for a drill bit when you're doing a split point grind. Now it is necessary when you shift from doing the 4-facet grind to the split point grind to move the drill in the chuck, and that's why you need to be able to set it at both steps. Okay, that brings us to the final upgrade, and it's for this little feed screw here. Now this is just a 4mm socket head screw, and because it's made of hardened steel, it's actually making a scored mark in the back of that block there. So I don't know if you can see that, but it's scoring into the surface of that aluminium there, and over time that's going to become an issue. So what I've done is I've made a new screw. Now it's made of brass and it's got a spring on it. Here it is here. So what we can do now is wind that all the way through. And the point of the screw comes out the other side. Now it's rounded over so it won't damage the aluminium. When this aluminium block here is anodized, it'll become a lot harder on the surface, and I'll get rid of that score mark before I do that step. And with the spring on there now, we can set it and it won't accidentally move when we go to index the drill bit around 180 degrees. And that's what I was finding was a problem when we were doing it with the screw here. Now, we're not out of the woods yet. The problem now is that because of the diameter at the head of that screw there, it clashes with the outside of the collet chuck. Now, there's no need for the collet chuck to be that long. I'm going to cut this off short, and that way we can use the screw more easily. It won't get in the way. The extension of the collet chuck won't get in the way. So we're going to do that now, and then we can get on and actually grind some drill bits. Okay, I've got a mark on there that's going to allow me to get the head of that setting screw clear of the end of the collet chuck. Now that's just a target mark. I'm going to cut this off with an angle grinder, and that's going to leave a ragged end on it, and I'll need to put this in the lathe and try and machine that accurately. The only problem is this steel is quite hard. It sort of is cutting with the file, and I'm hoping I can use a carbide insert in the lathe to clean this up. If that doesn't work, we'll need to use a grinder in the lathe, like a tool post grinder. But I'll go ahead and cut this short, and then we'll see if we can get that cleaned up. Alright, let's see if we can get that cleaned up in the lathe. Let's hope I've got a tool that'll do it. I just ground off that little broken piece so I don't get an interrupted cut, and that's a brand new carbide insert. Alright, piece of cake. We'll need to deburr inside there though. I'll put that back together now, and you can see the feed screw is extended through about 3 to 4 millimeters from the back of the collet block, and that's enough movement to do most drill bits. And the way this would work is you'd set up the drill bit, you'd have everything sort of aligned and set correctly, put it in the machine, do the first grind on the end of the drill, and then you'd loosen this screw here, make sure that your index ring is still locked, and then wind the feed screw out away from the back of the index ring, and then slide the whole collet chuck assembly forward, lock that screw again, do your next grind, and just incrementally move the drill bit forward using the feed screw as you go. Now, John Moran describes that process as scooching and yeah, it's just a description of that process of incrementally moving the drill bit toward the face of the grinding wheel. Okay, I guess we need to set up a drill bit now and actually sharpen one. So let's try and do a regular 4-facet grind on this drill bit here. So this is an 11mm diameter. It's well used, it's been resharpened, but it's been done offhand on a grinder. So what we need to do is find the appropriate size collet. In this case, this is 12 to 11. And we're going to put the drill bit in there, and then we're going to put this in the vise and tighten up the nut. So I'm just going to use these aluminium soft jaws here. Later on I'll make a proper fixture and it will grip on the 2 flats on the shank of the collet chuck, but for now this will work. So we're just going to run the collet nut up until it's sort of finger tight. The drill bit can still slide. We take our 8.8mm gauge, put that over the tip of the drill bit, and then slide the whole assembly back until it touches the face of the collet nut. Okay, tighten the nut. Don't need to really wrench it down tight, just so that it won't slip in or out or rotate. So this can go back into the collet chuck body now, and we'll rotate the cutting edges of the drill bit until they're horizontal. So I'm going to slip the nut of the collet chuck all the way back onto this end face of the collet chuck body, and then we can set the rotation of the drill bit. So I've got this little fixture sitting in the engineer's vise now. I'm going to reposition the camera so we're looking directly down the axis of the drill bit, and we'll set it in position. So here we are now positioned directly in front of that clear acrylic screen. You'll notice that the 2 cutting edges of the drill bit aren't lined up at that scribe mark. But we can rotate the body of the collet chuck now, and when it gets to there, I would lock the brass screw on the body of the collet chuck. Now what you'll notice is that one of the cutting edges is in line with that scribe mark, the other one is actually below it. Now you could reposition this screen. You could undo these 2 screws here and lower it down so that the scribe mark was directly on the axis of the drill bit, but I find it's better to have at least one of those cutting edges lined up with the scribe mark there. So let's lock it up there and get it in the machine. I'm going to run the carriage all the way across to the right hand side so that when we put our collet chuck assembly in the holes for the 118-degree point angle, the drill bit is clear of the grinding wheel. Now I've already set my travel stop so that that's as far as we can go, and the collet nut, it won't touch the surface of the grinding wheel. Now at the moment I've got the trunnion set up, so that will give us the secondary clearance angle on the tip of the drill. We need to set the primary angle, and according to my little chart here, the angle that we want for an 11mm drill bit is 12 degrees. So I've got my 12-degree template here, and these were laser cut. Later on we'll have the face of this eccentric here marked with all of the relevant angles. So I'm going to move the little sector plate out of the way so the trunnion plate drops down. We'll put that gauge underneath the trunnion, and I'm going to rotate the eccentric around until it's sitting on the carriage plate. At that point we can lock it, and now we've got our primary angle already set. So lift that up now, put it on the sector plate so we can grind the secondary clearance angle on the end of the drill. Okay, let's go. Now I found out the hard way, if you want to inspect the drill bit, turn the machine off and make sure the grinding wheel comes to a stop before you lift this out. Not a lot of clearance there, it's very easy to touch things in the wrong place. So not quite there yet, needs another grind. It's also important that you put the collet chuck back in the right set of holes. So I'm going to loosen the locking screw here, wind the feed screw outwards, and let the collet chuck move inwards and lock it again. So we're going to go ahead now and we'll do the primary angle, and all you need to do is put the collet chuck body back in place there and then sweep that sector plate out of the way so it's resting on the eccentric. So that lowers the angle. You don't need to do anything else, you just run the whole assembly back in front of the wheel again and that will grind the primary angle in the right place. Turn it over. And that's it. Just put the whole collet assembly in the engineer's vise here so we can rotate that and inspect it more carefully. Now the important thing is that the junction between the two facets on both sides of the drill, they intersect exactly at the apex of the drill bit, which is what you want. Now that happens automatically. You don't have to make any adjustments when you drop the trunnion plate down to do the primary clearance angle. You just grind it and that's how it turns out. Now I can't account for why this line at the back here where the primary and secondary clearance is curved. In reality it doesn't matter, and in theory this drill bit should cut. Now I say in theory because there can be a problem. Now this point of the drill here is called the heel. Now normally this would be not cutting or rubbing, it should be below the level of the cutting edge of the drill bit. Now I have sharpened the drill bit, put it in the drilling machine and tried it out, and it barely cuts, and when you take it out of the machine and look at it, you'll see there's a bright shiny patch right here on the heel of the drill. So that indicates that the heel is rubbing. Now you can just nick that off with like a bench grinder, just hold it up against the wheel and eyeball it and it will then cut. But you can do it in the 4-facet grinder as well using the split point jig. So this gives a more uniform look to the end of the drill bit and it works. So let's do that. Let's put it back and take those two corners off the heel there. This view here gives you a better look at the heel of the drill point. And when you look at that, it looks like this point here is higher than the outside edge of the cutting lip on the drill bit. And that's the problem. So we need to grind that bit off there. To swap over to that split point jig, we do need to reset the stick out on the drill bit, which is what I'm doing now. So I've got the nuts sort of just finger tight. Here's our gauge, and we just slide the whole drill bit back and we can lock that there. So I've just had to reset the cutting edge of the drill bit to our alignment jig here. So now we can go over the machine and grind that relief on the heel of the drill. Got that set up now. It's going to take a fairly deep grind on the first pass, but I think it'll be okay. I've got all my stops set, so let's see how it goes. So there's the heel ground off there now. You could keep going, and if you keep doing that, you will end up with a complete split point grind. But this should cut as it is now. I'll take a fraction more off, and then we'll take it over the machine. We'll try it out. I've just set the drill bit up in the Bridgeport because it's easier to get the camera in close. Now I'm running this at 600 RPM. This is a piece of hot rolled steel, and I'm going to use the automatic down feed. And remember, this is an 11mm drill bit. And I'm not going to center punch this. We're just going to start the drill bit on the flat surface of the stock. And the good thing about a 4-facet grind is that it should start accurately. It should not wander off. So I'll just add a bit of cutting oil though. Alright, piece of cake. That went much smoother than I thought actually. I haven't tried that drill bit out since I took it off the grinder. Cut through there quite nicely. It didn't wander at all, just started nice and clean and straight. So yeah, that's good. Now just for reference, I'm going to put a commercially ground split point drill in and we'll see how that looks. Right, this is the drill bit that I'm going to use. So this is brand new and this is a commercially ground split point drill. So it's got a regular conical grind for the relief, but in the back you'll see that there's a second grind angle and that produces that very distinctive point geometry. So we'll try this one and just for comparison. Well, I didn't notice a lot of difference there. That's the chip that this drill bit produced, and performance-wise I think they're about the same. But for what we've done here with this grind, I think it's performing quite well. Now we can turn this into a full split point geometry, so I'll go and do that now and then we'll try it again. Well, there you go, that was smooth and quiet, and that's the chip that it produced, so totally happy with that result. And you're probably saying, well, that's great, you've got a big drill bit and you've sharpened that, what about a smaller drill bit? I've actually done a 4mm bit yesterday, and rather than go through the whole process again, it's exactly the same, just you have to be a bit more careful when you're setting up the cutting edges horizontal, because you've got a smaller target to look at really. Let's put the 4mm bit in and see how that goes. So here's the 4mm bit. I'm running this one at 900 RPM, same feed rate. Just put a bit of cutting oil on there. We'll see how this one goes. Well, again, can't complain about that. It starts super accurately. There's no tendency for that to wander off, and it's just very, very quiet and consistent. So I'll give you a close look at the point of this one. So, is that showing up? So there it is there. Now I've done a bit of a grind to relieve the heel of that drill bit, but otherwise it's the same process as what I use for the 11mm bit. Alright, so yeah, successful, I think. Just to summarise, there's a really good look at the end of a drill bit that was done with the split point grind. Now, I'm not convinced that it's worth it to do that extra work to get a free cutting drill bit. Just removing the heel does seem to pay dividends, but there's a lot of work in grinding off all that metal. Now, I understand that a split point grind does give you a drill bit that starts more readily. It requires less end pressure to make a cut, and it tends to cut more concentrically. But like I say, just removing the heel seems to do the same job. Alright, let's wind up. Well, I think we're going to leave this project now. In the next episode, I'm going to have all of this machine stripped down, ready for metal finishing. So these painted parts on the corn wheel head are going to get sandblasted and powder coated. The aluminium parts are going to get anodized. The steel parts are going to be zinc plated or parkerized. And generally we're just going to make it look pretty. Now, I'm not going to go into a lot of detail though. I did do a playlist called Metal Finishing with Mark, and I went through all of those processes in more detail. Now, the link's up above there now, but this next video is just going to be more of an overview of all of that. Now, by the time we do the next video, I also hope to have the 200 grit wheel for this machine, and I want to be able to demonstrate sharpening small diameter drill bits. Now, this 80 grit wheel is likely to snap a drill bit because there's a bit of stick out and it's a very slender drill bit, and the sharp grit's likely to catch the end of the drill bit and break it off. But with the 200 grit wheel, that should be viable. So we'll do that as an update if I can make it work. Now, a lot of people have said, why don't you just buy a Drill Doctor? Yeah, you can do that. I can flash the credit card and buy whatever I want, but at the end of the day, I enjoy making tools in my home workshop. It teaches me new skills, it extends my capabilities, and you know, it's cheap. So yeah, I'm stingy, but I like making things. So I'm totally happy with the project so far. You do have to be a bit careful, and it's going to take some practice to learn how to use this more accurately. There's not a lot of clearance around the grinding wheel at either end, depending on which accessories you're using, so you've got to be focused and got to be careful, but I'm pretty sure I can make this work. Now, I'm going to finish up today with some video footage of some kangaroos that have been hanging around our place. There's a mother and a joey, and the previous year's joey has been hanging around with his mum, and a big male kangaroo that's been around as well. So we'll take a look at that, and I'm going to ask you to come back next time. We'll do the finish up on this project, and then I've got some other exciting things to do. So certainly come back. Okay, it's Prezzo. I'll see you next time. Cheers. The little Joey's not so little anymore. Half time he's in the pouch, he's got his back legs and tail sticking out. Or he's got his head sticking out. He can have a feed while mum's having a feed. Must be quite a load to carry around. I often wonder what the first European settlers thought when they saw this. It must have been so bizarre. This is last year's Joey, still hanging around with mum, and this big male that's often with them, but he's not here today.